In this video, we're going to take a look at a question that's going to require you to really understand how breadth-first traversal works. So inside my code editor, I'm going to find the level width folder and then open up the index.js file. And then as usual, we'll also flip on over to our terminal. We'll do just level width test.js -- watch. And I think we have about 3 tests or so. Okay, 3 tests, yeah. All right, let's go back over and read the directions here. So the directions say, given the root node of a tree, we want to return an array where each element is the width of the tree at a given level. Well, these directions aren't the most helpful thing in the world, so let's take a look at the code example here. So here's the sample tree. This would be a tree that you and I are given. Notice how it has the element up top, 3 children underneath that, and then 2 of those children have 1 element as children. So the example here, for this given example, we would return an array of 1, 3, 2. So let's talk about exactly where this array is coming from. Notice how the first level of the tree, so the very first level, the root level, has exactly 1 node in it. So the first element in our answer array would be 1 because it has a width of 1 at the first level. We would then move down to the next level. So here's level 2. Level 2 has 3 nodes, 1, 2, 3. And so in our answer array, we would place 3 at index 2. And then moving on to level 3, so here's the 3rd level, there are 2 nodes here. And so the next index in our array would contain 2. Again, each of these values are telling us the width of the tree or the number of nodes at a particular level. And then the index of each value is telling us the level that we are describing. So level 1, level 2, level 3 corresponds to index 1, index 2, index 3 in the array. So hopefully that makes sense. All right, hopefully that is not the worst thing in the world. So let's now talk about 2 particular things. I first want to throw out one kind of caution note here, one thing that you just need to be aware of, and then we'll talk about one possible way of solving this. So the first kind of caution note I want to share with you here is notice that the directions say given the root node of a tree. So we are working with a node here. And in fact, if you look at the project directory for level width, you'll see the node.js file inside of here. And so this is an individual node that we're working with. We're not working with the tree class anymore. We're not accessing the tree class. There is no tree class. All we are working with is the node class. And this node has values data and children, just like it did previously. So that's what root is. Root is a node. Just keep that in mind. Now, as far as the solution goes, the instant in any tree-related question, the instant you see the word width, anytime you see width, you immediately want to start thinking about a breadth-first traversal of our tree. And that's exactly what we're going to do to solve this question. So let's kind of think about how we could use breadth-first traversal to get the width of each level here. Now I'm going to give you one possible solution to this problem. This is just one possible solution. There could be more. Give it your own shot if you want to try to come up with your own solution or if you have a thought on how to address this. I'm just going to show you one possible way of doing this. So for our solution here, we're going to maintain 2 separate arrays. Okay, one is going to be called counters. Counters will be the array that holds the actual width of our tree at each level. So counters right here would be the array that we eventually want to return from our array, or excuse me, from our function. Then we're also going to have the array, and this array right here is going to serve the purpose of that kind of buffer or that kind of queue that we're going to use to iterate through our tree in a breadth-first fashion, just in the same way as we did a moment ago. Now, when we start to implement this question, you might be thinking, okay, we're going to reuse that exact same traverse breadth-first function that we did previously, but that's not quite the case here. Instead, we are going to iterate through our tree in a fashion very similar to breadth-first traversal, but we're going to rewrite all that iteration logic, and we're going to add a couple steps here and there. So any type of tree problem that you run into in an interview, very frequently, you're not going to be using some pre-built traversal function. Instead, you're going to have to write a function that will traverse through the tree and do some work during that traversal. And that's exactly what's going to happen here. So we're going to write some code to traverse through the tree, and at some points in time, we're going to do some extra little bit of work. All right, so let's give this a shot. So the first thing we're going to do before we start doing any iteration is to create this starter array right here, just like we did previously. It's going to contain the root node, and then we're also going to insert some random token in here. Some number, string, it could be null, whatever you want it to be, just some kind of pointer or kind of note to ourselves. And so in my case, I'm going to use a string of s. So this is going to be not a node. Remember, 20 is going to be a node. This is going to be simply a character that I'll call s. And this can be absolutely anything. It could be the value null. It could be a straight number that's not a node. It could be a string, totally up to you. You'll see what its purpose in just a second. So before we start any while loop or anything like that, we're going to create our base array and put the first node and this kind of stopper variable in there. We will also initialize the counters variable, or excuse me, the counters array, and give it a starting index or a starting value of 0. So the first element in counters will be 0. Okay, now we're going to enter into our loop, and we will kind of discuss and walk through the loop and think about what's going to happen inside of it. So inside of our loop, we're going to take out the value 20. So the very first node, just like we did previously. We will then take any elements or any children that 20 has, and we will add them to our array at the very end, just like we did before. And I'm going to move things over just a little bit to give myself a little bit of space. Okay. After adding 20, or all the children of 20 into our array, we're going to increment the first counter right here by 1. So that's going to say, okay, at the very first level of our tree, we had 1 element. So we were 1 element wide. So we've processed 20. We've done everything we need to do with 20. So we'll throw it out to the side here. Next, we will pop out the next value from the array. And this time, we're going to get this kind of stopper value. And that's why I called it s right here. It's kind of like a stop, or kind of like an end-of-line character. So we're going to say that anytime we see this end-of-line value right here, that must mean that we've hit the end of some level in our tree, and we need to now start to assume that we are processing values on the next level. So anytime we see the value s right here, we're going to do two things. We're going to take the value s and put it back at the very end of our array. Because anytime we see s as the next value in here, that means we have processed an entire level. We just processed everything on this level right here. So we have taken all the children from the elements in this row right here, and we've inserted it into the array. And so everything after the last node that is currently in the array must be the formation of the next level. So in this case, see how we have 0, 40, negative 15? That is everything out of this level right here. So there's nothing else to be processed, so we will stick s at the end to signify that is the end of this current level. So step 1, just to reiterate, as soon as we saw that we had s, we would take s and stick it back onto the end of our array. And then the other thing that we're going to do is add on a 0 to the end of our counters array. The purpose of adding on this 0 right here is, again, to signify that we are now moving on to the next level of our counter, of our tree. And so we're going to start attributing all the nodes that we see from now on to this new last counter in here. So we then re-enter our while loop. We take out 0. We see that it is a regular node. We check to see if 0 has any children, and it does. So we're going to take all those children and then stick them on to the end of the array over here after s. After taking all of its children and inserting them into the array, we'll then go up to our counters array. We'll find the very last value in there, and we will increment it by 1. And then we'll throw that thing away. Next, we take out 40. 40 has no children, so we will just increment our current counter, or the last value inside of counters, by 1, and we'll throw the node away. We take out negative 15. We add its children to our array. So we would take this negative 2 right here and add it onto the array. We would then increment our counter variable by 1, so we're now up to 3, and then we throw 15 away. And now we move on to the next value. Again, we find s here. And so anytime we find s, we're going to throw s to the end of our array, and then we create a new entry in our counters array and initialize it to 0. We re-enter the while loop. We take out the 12 right here. 12 has no children, so we increment counters. We throw 12 away. We take out -2. It has no children, so we increment counters. We take out 1. It has no children, so we increment counters. And I think you see where this is going. We take out -2, and we increment counters. So it's now up to 4. Now, at the very last step of our for loop, or excuse me, our while loop here, and this is something that's really critical, we need to consider the very last condition here. So we've said that every single time that we see the value s, we take out s, and we add it into the end of our array. However, if that is always the rule 100% of the time, then we would very quickly enter into an infinite loop, because we've said that every single time we take out s, we add it to the end of the array. And remember, when we did our breadth first traversal algorithm, we said as long as there is an element in our array, we should continue iterating through it. And so that would just very directly lead to an infinite loop where we keep on taking s out and then putting it back in, taking it out, putting it back in. So for our breadth first algorithm this time around, maybe we don't want to be only considering the array's length right here. Maybe we want to make sure that as long as there is more than one element in the array, we should continue iterating. Because think about it, anytime there's only one element, the last element should always be s. So if there's only one element, well, that means that we actually don't really have anything else to iterate through. Now, the one thing I'll caution you against is only checking to see if the first element is s here, and then using that to decide whether or not we should continue iterating. So if we only check to see if s is the first element and then decide to say, okay, s is the first element, stop, well, we would never catch the case in which there's some value after it. So in short, if you see that there's only a length of 1 in array, then chances are only s is in there and we should probably stop iterating. Now, as soon as we finish iterating through the array, we then have our counters array right here, which has been maintaining the width of our tree. And so notice the final arguments or the final values we get in here. The first level right here has a value of 1, so that's definitely the width. Then we have 1, 2, 3 elements at the next level. We have 3 right there. And we have 1, 2, 3, 4 elements at the next level. So we have 4 there as well. So that's pretty much it. That is one possible solution, one possible way of approaching this problem. So if you can think of another way of tackling this, hey, certainly go for it. But this is just a way that I think builds very nicely on the breadth first traversal algorithm that we were just looking at. So let's take a break right here. I would really encourage you to give this problem a shot. Try it out on your own. Make sure that you can really come up with this solution. And in the next video, we'll go over the solution together. So give it a shot, and I'll see you in just a minute.